Hello, welcome to a video for physics. In this video, I'm going to be going over some of the problems that we didn't get a chance to go over in class because we ran out of time. This one is number 54 in your chapter assessment. You guys had a question over that one, and I want to make sure that I'm able to cover it at least in the video so you can use this to study. Okay, so let's dive right into this problem, shall we? So the problem states a 65 kilogram diver jumps off of a 10-meter tower. Assume the air resistance is negligible. So find the diver's velocity when the diver hits the water. And then secondly, the diver comes to a stop 2 meters below the surface. Find the net force exerted by water. Okay, well, let's look at the first one. So here I have a little diagram. The 65 kilogram diver is my orange box up here. And then that's the tower, the red triangle there, 10 meters high. So that's my height. And this is the equation that I'm going to use. I'm using this equation because the problem is asking for final velocity. It's asking for the velocity of the diver when he hits the water. So that means I'm going to be looking for my VF. Alright, so in order to find my VF, I need to know the quantity, the value of my other variables in this equation. So this variable reads as such: velocity final squared equals velocity initial squared plus 2 times the acceleration times x final minus x initial, or distance, d. Okay, so again, my velocity final, because I'm looking for the velocity as it hits the water. So I'm looking at it right at that instant before it hits water. Okay, and that's how I know. Because as I look at my problem, I'm looking at the keywords that are going to help me. And here's some things that I know based off of the problem. The diver is jumping off. So that's a clue as to the value of one of my variables, because if he's jumping off, that means gravity is taking hold of him as he falls. So that means I know acceleration. And my acceleration will be 9.8. Now I also know my distance because the problem tells me it's a 10-meter tower. So I know my x final, okay, my x final will be 10 and my x initial will be 0. So that's 10 meters. That's my distance. So those are the two variables that I now have values for. Acceleration is actually g, which is 9.8, gravity, meters per second squared, and then my distance is 10 meters. So I can now replace those variables with what I know. And now that I have them, I can plug and chug at this point. But as you can see, there is one more variable. That's my velocity initial. So what's the initial velocity of my diver? Well, as he stands on top of the tower, he's actually not moving, so there is no velocity. My velocity initial will be 0 squared. So now I can actually just start computing, and let me back up one more. So, so then 2 times my gravity times my distance will give me 196. And of course I have to square root that to get rid of that square. Square root 196, and that gives me 14 meters per second. And I know it's meters per second because I'm looking for velocity final. So this object, the instant before it hits the water, as it hits the water, its high velocity is 14 meters per second. Okay, and that's my A, because I wanted to find that velocity. Now, let's see if this is going to be useful for part B. Part B is asking, the diver comes to a stop 2 meters below the surface, and it wants me to find the net force exerted by water. That's very key because it's asking for the force exerted by water, not by the diver himself. So let's change my diagram a little bit because now I'm focusing on the bottom part. So he stopped 2 meters below the surface, right? So then that means that my velocity final is now going to be my velocity initial. Okay, take a second to kind of absorb that for a second. Why is it that I'm switched? Well, because now my reference point is different. Now my beginning point is the instant the diver hits the water, and then my final point is when he comes to a stop. So my velocity final is when he stopped, so that means it's 0 meters per second. And my initial velocity is which is when he is just hitting the water, which is he's at his max velocity, is 14 meters per second. So it kind of switched. It switched there. And it switched because my point of reference switched. And now my distance is actually changing too because now it's 2 meters. So as my diver hit the water, it took him 2 meters to come to a complete stop. And that's because the water was exerting a force on him. So the diver exerted a force on the water, but the problem isn't asking me the net force of the diver on the water. The problem is asking me find the net force exerted by the water, so the force that's actually pushing up against the diver. So I'm using my same equation, right? I'm using my same equation, so I can plug in my VF and my VI. Okay, so you see how that works there. And now, if I look at the second part of my equation, it's 2a times my distance, and I know my distance to be 2 meters, and I'm looking for a. Now, why would I be looking for a, right? I'm looking for that variable. Why am I looking for that? We are looking for acceleration because the problem is asking for a net force exerted by the water. So we're actually going to find the force, my F, my net force of water going in the opposite direction the diver was. So in order to find force, I need mass times acceleration. And I already have a mass from the problem, don't I? Because if you go back to the problem tells me that the diver is 65 kilograms. Now I just need to find the amount of mass, or the acceleration in the opposite direction of how he's falling. Because I know the acceleration of him going down, that's 9.8 meters per second squared. But what's the reverse acceleration that's causing him to slow down? Think about this logically for a second. So he fell 10 meters at 99.8 meters per second squared. But how far did it take for him to come to a stop? 2 meters. 2 meters compared to 10 meters. That means the acceleration going in the opposite direction is going to be greater than the acceleration going down. And let's see if the math actually plays out. So we have our numbers, 14 squared plus 2a times 2. Let's plug and chug and see what we come up with. So 14 squared is 196. 2 times 2 is 4. And so I'm still looking for a. I'm isolating my variable, so I'm going to move over 196. And now I'm going to divide by 4. And that gives me the value of a, which is 49 meters per second squared, negative 49. And I have negative because that acceleration is going in the opposite direction than the diver. The diver is going down, but the water is pushing up at negative 49 meters per second squared. And the water slows him down pretty quickly, right? So I have my value for A, and I also have my value for M, which the problem gave me at 65 kilograms. I plug and I chug, and the net force that the water exerts on the man, on the diver, is negative 3,185 newtons. That's quite a bit. Okay, well, that does it for that problem, and I hope this helps, and good luck in your studying.